Here we come to DSE Physics 2020, question 4. Here we have a ball released down a smooth track, go to the lowest point B, and then go up again to point C, where it is released and projected along a projectile path until it hits the ground E. So basically we can divide this motion into two. First of all is when it is released through the smooth track. This is the motion that we can calculate with the conservation of energy. Second part of the motion is after it is projected and released, and this is a projectile motion, so we can use the projectile motion technique to solve it. So first of all, part A, arrange the speed of sphere at point A, B, C, and D respectively. We know that it is a conversion of energy. So when the PE is higher, KE will be lower, vice versa. So whenever the ball is higher, the KE would be smaller. So arrange the height of the points A, B, C, D. We can see that A is the highest, then D, then C, then B. Okay, so the order is A, D, C, B. A larger than D, larger than C, larger than B. So the KE, which is proportional to the speed, would be in the order B, C, D, A. B has the highest has the highest speed, and then C, and then D, and then A. Part B. On figure 4.1, use arrows to indicate the acceleration. Okay, so we want to indicate the acceleration. Firstly, let's look at point D. Point D, at this point, the sphere is acted on by gravity only. So the acceleration should be vertically downward. So the acceleration at D is in here. Now for point B, we know that the ball is performing a motion. It slides down first, and then it goes up again. If we focus at this section, the sphere is more or less performing a turn along this circular path. Okay, it's performing a circular motion. So in a circular motion, we know that the acceleration is pointing towards the center of the circle. So at point B, the acceleration is in this direction. You can look at it in another way. Let's say this is the sphere at point B, and it is sitting above the smooth track. So if you consider the force acting on the sphere, firstly, the sphere is acted on by a gravitational force, and also we have a reaction force from the ground. So it would be equivalent to a force that is acting upwards. Okay, so it is the net force acting on the ball when it is at point B. So therefore, if the net force is acting upwards, the acceleration would also be acting upwards. So the acceleration at point D points downwards, and the acceleration at point B points upwards. Part C. Firstly, describe the energy conversion of the sphere when it goes along the track A, B, C. So that is the green part. So we can divide into two sections. Firstly, when the ball goes from A to B, here PE is lost and it turns to KE, so we have PE change to KE. After it goes through the lowest point B, it goes up again. So it would change its KE into PE. So there are two sections, so we can write that down. From A to B, GPE to KE, B to C, KE, convert to GPE. Okay, and then part 2, we have to find the speed of the sphere at point C. At point C, the total amount of energy would be equal to the amount of energy at point A. Here we can take the ground as a reference. That means we can measure the height and the PE from the ground, assuming it is 0. The PE is 0 at the ground. So at A, we have only got PE and no KE because it's released from rest. At point C, it has some PE. It has also got some KE. Okay, and this total amount will be equal to the total amount at point A. These two amounts will be equal. So by conservation of energy, we can write down an equation. At first, we have PE given by mgh. And then at point C, we have the PE given by mgh and KE given by half mv squared. So m is cancel out on both sides. HA is 2.2. G is taken at 9.81. Hc is 1.0. And we have this equation. So solving this equation, we got Vc is equals to 4.8522 meter per second. Part 3. After the ball is released, we know that it follows a projectile motion from C to D to E. It is given that the horizontal between C and E is 2.55 meter. That means if I indicate it here, the horizontal distance between C and E, I call it Sx, is 2.55 meter. So we are going to find the time of flight of the sphere before reaching point E. So let us assume, let's take this point C as the starting point, and we are going to find the time at point E. Here we can indicate that, in order to be clear, I erase this first. We can indicate the speed or velocity at point C by this arrow. So I call it U. U is equals to 4.85. And we can resolve this into Ux, which is given by 4.85 cosine 60, and the vertical part, Uy. uy is equal to 4.85 sine 60 degree. Now, because we know, we know the horizontal component of the velocity, we also know the horizontal distance. So we can simply use these two information in order to calculate for the time of flight. Consider the horizontal motion. Sx is equals to uxt. So t is equals to sx over ux, which is equals to 2.55 over 4.85 cosine 60 degree. And this will give us as 1.05 second.